In this week's lesson, it's all about correlation. Correlation is a relationship between two variables. The definition of correlation is a numerical coefficient which indicates the extent which the direction to which two variables are related or associated. It is basically called the Pearson product moment correlation coefficient. Okay, that's the long word for it. The bottom line is that we're looking at a relationship between two variables. Again, if you look at anything that we could look at, such as height and weight, times hitting the ball versus not times hitting the ball, there are tons of things that we can look at over the period of the year. You could look at GPA to test scores, anything that is independent of each other. When we look at the correlation itself, the numbers range between +1 and -1. Okay? All the numbers that will be reported will be between these two numbers. There are two types. There's parametric and non-parametric. The parametric is up here. It's a linear relationship. It's Pearson correlation, which most of the stuff we will be doing here. Down here, we're looking at ordinal, ordered numbers, continuous, categorical variables. We'll be looking at associating with Likert score on work satisfaction and work output, pain intensity. Okay, so we'll be dealing mostly with this one right here in the next, especially in the next section, in Module 2. Here's where it becomes, hopefully we can make this a little clearer. Decimal number, the correlation coefficient, the letter is R. R, little r. It is italicized. Okay? Decimal number, again, between 0 and +1 or -1 that indicates the degree which the two quantitative variables are related. Okay, so you can see the 0 here. That's in the middle. It's a number line, but not like the number line you had when you were in elementary school. 0 in the middle, if you came out with a number of 0, you have absolutely no relationship between the numbers. No correlations whatsoever. If we come over here to the negative, this is the negative side, and this is the positive side. Each one of these ones right here is called a perfect correlation. Okay? Going to the negative, this would be a strong negative, and this would be a strong positive. Okay? Each of the ones are perfect. So as you go out to the one, it can't be higher than a 1. So once it gets to 1, it's perfect. Again, now we're back on that same number line. Here's your -1. Here's your +1. Okay? Down here, you have 0, which is no correlation. So let's say I get a number of 0.444. Okay? It doesn't matter whether it is positive or negative. This number right here and this number right here are exactly the same. The only differences in the two is one is negative and one is positive. And it's all about direction. Okay? As we talk about these numbers and we put them into perspective, if they're both the same, what is the difference? Again, it's the negative and the positive. Okay, so if the positive number comes out, so like 0.444, that means that both sets of scores from score 1 and score 2 both went up. Okay, so I'm taking a test with two numbers, batting average and times at bat. Okay, and both of them went up as the numbers went in. Okay? Over here for the negative, one goes up and one goes down. So as number of times times a batter stepped in the batter's plate to hit the ball, stepped up to home plate to hit the ball, the batting average went down, or vice versa. Okay? One goes up, one goes down for the negative, and both scores are going up. Okay? The difference from the mean is how you get the coefficient. So the farther away from the mean from what the actual number is, you're either going to have a positive or a negative relationship. Positive correlations result when participants receive high scores on one variable and receives high score on another variable. So, as we said before, negative correlation, one goes up and one goes down. So we're going to look at 3 sets of data here. And this is probably one of the easiest ways to get a visual. Very simple. You'll see that there's a 1 right here. Okay? Positive 1. You can see that X and Y, these are not different people. This is different times. So X is one time and Y is another. 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. You got a positive. Okay? Both scores are going up. Negative here. One set of scores goes up and one set of scores go down. Okay? Then you have a 0 correlation. That's where none of the scores even come close to matching. Again, perfect correlation is either 1.00 or negative 1.00. Now we're going to talk about strength. So, a 0.70. So if it came out 0.700, it's a strong negative correlation. 0.50 is a moderate. 0.30 is a weak negative relationship, and 0 is none. So if I gave you a number of 0.840, it would show you if that's positive because there's no negative sign. So it would be a positive, strong, positive correlation at this number. This was now if we do another number of 0.111, now we're down here at weak, so we could say a weak, make it negative, negative correlation. You can put linear in there, but we all know that. Correlation does not imply causation. So you could have a correlation of the two numbers. Let's take times at bat and batting average. We can find easily if both are going up and one is going up and one's going down. But there are other factors that take care of that. Okay, what's some of the factors? Batting stance, hitting, good stride, good swing, perfect pitch selection. There's all these things. So you can note that this is happening, but it may not be the cause of the batting increase. Okay, the number of at bats could be a portion of it, but an improved swing, an improved stride, better mental aspect of the game, being more patient on which pitches they hit, could be the reason. So it does not, you may find correlation, but it may not be totally caused by the two things that you're speaking of. Here is a actual definition of it. Scatter plot. When you're talking about a scatter plot, you're talking about something where you have one on an x-axis and one on a y-axis, and this is how you're going to be able to look at your actual correlation. So here's a positive correlation. You can always see it's going up. Okay, all these little stars here are each of the scores. So we're looking at triple jump and long jump. Triple jump versus long jump. So you can see in this case, since it's positive, we should both know that they're both going to go up. It's kind of a cheat. Okay? You see that the numbers are going up. So as long jump goes up, triple jump goes up. It's real simple. You're looking at the dots. You can see that they are correlated. They're also correlated in a line that makes them look positive. You'll see that it's uphill. Okay? Both of them are going to go up. So as triple jump goes up, long jump goes up. Now you see that this is a downhill line here, which is called the best fit line. You'll see all the dots around it, but it's going down. So we're doing a 100-meter dash and long jump. Okay? So as long jump, we're going to go up and down now in a negative. In the negative. Okay? So in this case, as long jump goes up, okay, 100-meter times go down. Okay? So you can see this. If they jump 3 feet in the long jump, they were running 40 miles. As long jump went up, the scores right here went down. So the time went down. So these were better times the farther they jumped. The shorter they jumped, these times were worse. This right here, there is absolutely no best fit line because the scores are all over the place, and this would be no correlation. Now we're going to talk about the coefficient of determination. It's R squared. Okay? So we need to know, not only do we need to know if it's correlated, but how much it's correlated. Okay? So understand this. This number right here is the correlation number. It's a negative, okay? So it's a weak negative correlation at 0.194. Okay? 194. Okay? Now, we are going to take that number and we are going to square it to come out with 0.44. Okay? So, there's the square. There's the thing. So, it's basically 44%. Okay? So, in this one, we're looking at total points on the quizzes and was it explained by students' GPA. Okay? So, we know it had one went up and one went down. Okay? But we don't know how much it overlapped. Now, what's overlapping? The total points and the GPA. That's what we're looking at overlapping. Okay? So if we take this and we overlap the two, okay, we're going to come up with 44% of the variability between the two are actually being super correlated. I like to call it super correlated. This is just a little bit more on it. It's R2. Okay. It's called the coefficient of determination. Okay. So now, in that last one, we had scores. Oops. And over here, we had GPA. Okay. This right here is the 44%. So 44% had a common variance between scores and GPA. Now we're moving into exam review. When we come into class, we will be, after class is over, we will be taking an exam. Okay? So correlation is one area. You need to understand what a positive a negative, perfect correlation is. You need to understand the direction. Okay? understanding the difference between a negative and a positive. One goes up, one goes down, will go up. Perfect correlation and no correlation. You need to understand what all those are. You need to understand what a positive skew and what it looks like, a negative skew and a normal distribution. Okay? Understand the definitions and everything about mean, mode, and median, variable, parameter, and statistic, and what descriptive statistics are, and what inferential statistics are. And that will be all on the exam.